Let's deploy an e-commerce system on Google Cloud using Kubernetes. Okay, so this is the application that we want to deploy on Google Cloud platform using Kubernetes. It has got a web application and it has got a load balancer in front of it. Similarly, we have services which are basically one single application right now. They also have got a load balancer, and then these services are using a Postgres DB, which has got one instance because it's an RDBMS. And then we have another DB being used by business services, that is Cassandra DB, and we are using Cassandra cluster with 3 nodes. Uh, Once we deploy this basic deployment, then we will move to a more complex deployment, which we will do very easily through a script. What will happen over here is our business service will be converted into a full-fledged microservice, and so that will be replaced with gateway service and services which represents various modules like authorization, user profile, catalog, order, inventory. uh, each of them will have their own load balancer called service in Kubernetes. The database, they'll remain the same. So once we have achieved this, we will put some load on Kubernetes. What that load will do is that it will force this system to scale horizontally and increase the number of instances. So it should look like this. So depending upon the load and the configuration, the system will try to increase the number of instances for web application as well as the services. And this is what we are going to see in the demo. One thing that we may like to quickly check is that in order to deploy this system, we will need Docker packaged application, and these Docker packages or Docker images, they are there in Google Container Registry. So Kubernetes configuration is aware of the location of these Docker images that are required, and it will pull these images as and when it is deploying the system. So let's jump into the deployment now. Okay, so I have opened a browser. Let's just first go to Google Cloud Console. Let's check what all machines we have already in this. So we'll go to Compute Engine. There is one machine for which we'll also have a disk associated with it. So we'll ignore this machine. This I have kept for some other use and I'm not going to delete it. So it will be here. We'll have to ignore it for this demo. So one more thing that needs to be ignored is I'm showing you the disks which are here. This instance build disk, this has to be ignored. Okay, so the first thing that we need to do over here is we need to create a Kubernetes cluster. Kubernetes cluster is a set of nodes. So we will create a cluster with 12 nodes, and we can create that by going to Kubernetes console. There is a create cluster UI for this, so we'll hit this create cluster button. Here we can give this cluster a name. We can select the zone. In this case we will select Asia South 1A, which is a Mumbai zone in India, and we can select Google Kubernetes version, and then we can select the number of nodes. We can do certain firewall settings. We can choose the kind of machine that we want. So we are going to choose this one CPU machine with 3.75 GB memory. We will have 12 such machines. So rest of the configuration I have already done. So in this, so whenever you do this configuration, you can come to this link of command line. This will give you a command line with all the options that you have selected. So I have already prepared this command line, and I'm going to run that in the interest of time. And there will be a couple of more scripts that I'll be running just to save time. Okay, so I have launched create cluster. This cluster creation will take some time. So I'll pause this video and we'll come back. We'll have to do this at each stage where each of our action takes some time. So we'll continue to pause and play again. Okay, so see you again. Okay, the cluster command has run. It should have created 12 nodes. Let's just verify that quickly. Okay, so these are VM instances. There are 12 of them which are created for Kubernetes cluster. So we have total 45 GB memory in this cluster and about 12 processors. Okay, so from here, the next thing that we need to do is we um, need to deploy our application. But before we deploy, let's just check uh, what all are the disks that are available over here. So if you see all these 10 GB disks, they are hard disks for each of these instances that have got created. We need to create, before we deploy our application, we need to create a disk for permanent storage of our databases. We do not want to store that data on the standard disks attached to our machines because they can be reclaimed back. Okay, so let's do that first. Let's create, I'll just quickly issue a command that should create at least one disk right now, and we'll do provisioning for 3 other disks for Cassandra cluster. Let's just check that. Okay, so this one is created for Postgres, and once Cassandra cluster comes up, we will see 3 more disks apart from this. Okay, so let's deploy our application. Our application is being deployed now. While it is getting deployed, let's just check the number of disks. These 1 GB disks, they belong to databases, and we'll see as our application is getting deployed, these number of disks will increase. The number of instances will remain the same. There'll be 12. Okay, going back to Kubernetes console, cluster will remain as is, and let's check the workloads. Workloads are getting created right now. Cassandra, 3 nodes have to be created. It seems right now only 1 node is up. This REST service, which is our business application, that will be deployed only once all the databases are up. The databases are Postgres, we'll have 1 instance, and Cassandra. This Eureka is registry and we are not using it right now, but it's anyway deployed, we can ignore it. Okay, so let's just check what are the services which are there. Services are kind of load balancers. So we have that ready for Cassandra, we have it ready for web application, we have a load balancer ready for RESTful service, and similarly for Postgres. The one which we are particularly interested is in this web load balancer. It is of type node port, meaning we are not using Google Cloud Platform's load balancer. That's going to cost us for this demo. So in order to save our cost, we are using node port, wherein we can call um, we can make an HTTP call to any machine, any node and we'll have one port open on each of these machines, and that port is 30,000. uh, that's what I have configured. And so these are the external IP of these machines, so we can pick up any external IP. Let's say we can take this, and if we access uh, port 30,000, we should be able to access our application, and we can see that our page has come up, but the application will work only after all the components are deployed. So let's just check if all of them are deployed or not. These are services. Let's just see workloads. Workload REST service is still being deployed. There are about five, six modules in this, so it will take a little time for it to deploy. So we'll pause the video and come back. Okay, looks like our REST service has come up, so our system should be ready as indicated by all these statuses over here. So we are ready to check our application once again. So let's hit that. Um, let's try to log in. Okay, so we have logged in. Right now there are no products in this, so we'll have to create some products. So let's do that. Let's create 10 products. Let's wait for a few seconds before they are created. Okay, looks like that is done. So let's check if we have something. Okay, so we have products. We can take any of these products, select some quantity, add to cart, and go to cart. Cart has this item, then create order. Order has been created. We can now check the orders. Okay, we have an order with this order ID and with so and so with the product that we have selected and the quantity that we have selected. Okay, so seems like application is working fine. So it's time for us to uh, convert our service into microservice. So let's do that. In order to convert our business application into microservices, I'm going to run a command. I've already created a script for that. And so this is not a Kubernetes command, but a set of Kubernetes commands wherein we'll remove the old business application, and one by one we will create new services or microservices. So let's just do that. So this will do all the configuration. In another demo, we'll go in the detail how to go about this, but right now we'll quickly look at what's the effect of this. Okay, so script has run. Uh, it would have triggered the creation of microservices. So let's just go and check that. Okay, let's refresh our workloads. Okay, so as we can see, there are new services which are created: admin service, auth service, gateway service, inventory service, order service, product service, user profile service, web service. It will take a while before all these services come up, so we'll pause the video and come back. Okay, all services are up. Let's refresh them once again and see the number of instances that are there. For admin service, we have one instance which is ready. For auth service, we have one instance. Cassandra, we already had 3 instances running. Similarly, for other pods also, we have one instances running. For web, it seems there are 2 instances. Looks like the some of the testing that we have done that has triggered creation of one more instance. So let's just check the application before we go to the next stage of scaling up this application. Let's just check if this is working fine. Okay, I can see the products, and I can choose some quantity, add to cart. go to cart, create orders. Okay, and then orders. Okay, so there are two orders in the system now. Okay, that's good. So let's go to the next stage wherein we will put some load on the system to force it to increase the number of instances. So I have given some target of 75%. If CPU exceeds for any service above 75%, then it will create more instances. So let's do that. For that, I will run some tests through JMeter. Let's trigger them. Okay, we'll wait for it. Let's see if there is something happening on this side. Okay, for order, we see that it says that we do not have minimum availability because we have raised minimum availability target to 2 from 1, and we need 2 instances, so order is being modified. That should be the case with other services too. Okay, that will happen in a while. Seems like load test is still getting triggered. Let's go back to load test. Okay, some issue over here. I'll try to run it manually just to see the log of this load test. Okay, this load test is running. Okay, so we see that the gateway service, now the target has been exceeded to 2, and so wherever, depending upon the load, okay, now we see on auth service also, the target is actually now 3 instances. There's fair bit of load on auth service, so it has to increase its number of instances. So that will continue to happen, as in wherever the system will detect that more number of CPUs are needed, it will actually launch more instances. So we'll have to wait for them. Order, it seems it's already at 2. Gateway and auth, they are still in progress. So while they are in progress, let's just see how our app is behaving while our application is scaling. Uh, Seems like everything is working fine. We have no issue in seeing products, adding items to cart, and then creating order. All of that is working perfectly fine. Service status also I can see. So seems like application is working perfectly fine. Let's just refresh this, and these instances are still coming up. So while they're coming up, our application is still working fine. What we will do is we will launch this test once again, and I'm deleting the old instance of this test and launching it again so that there is continued load on this system. If the load goes down after some time, the system will actually bring down the number of instances, which is what we want, but not right now. Right now we want to see more number of instances as per the load. So these services, they're Spring services. They take a fair bit of time to, new instances take a fair bit of time to come up. So that's why it takes time. We'll just wait for a few more seconds, otherwise I'll pause the video. It seems auth is already done. It's just we are waiting for gateway service. In the meantime, we can again check if application is working fine. Yes, application is responding the way it should. We are able to create orders, we are able to see the orders. So enough orders we have created during this process to make sure that our system, while it is scaling, is still working. And the last bit of this demo is also done. Gateway service is also scaled. So right now we have 3 instances of auth service, 2 instances of gateway, 2 instances of order service, and this is as per the load that the system is experiencing right now. So that was the demo. With this we will close the demo now. Thank you for watching the demo. Have a good day.